Good morning, everybody. Today we're going to review TEK 8.5c, which is interpreting the arrangement of the periodic table, including the groups and periods, to explain how properties are used to classify elements. And of course, the first thing we need for this activity is our periodic table. And we're going to start like we would always start off. We're going to start by looking at what we need to remember to do every time we see a periodic table, which is first off to, circle the atomic number, because that reminds us that atomic number is equal to protons, which are equal to electrons. This is our ape number, and we are also going to circle the atomic mass to remember this is our man. Mass minus atomic number gives us the number of neutrons. So if we want to know what the protons and electrons are for any element, remember we look at that top number in any given element key to see what the protons and the electrons are. And the bottom number we always round to see how to calculate the neutrons. So for example, 6.94 would round to 7. 7 minus the 3 would give us 4 neutrons for lithium. Beryllium, 9.01 would round to 9, mass number of 9, minus the atomic number 4 gives us 5 neutrons. So just a quick reminder on how we gather that information. So as we all know by this point, the periodic table of elements lists all the elements or all the pure substances. Hence, it is a periodic table of elements. You will not find the compounds here. Compounds are a combination of 2 or more different elements. So, next thing we know by now is that the protons determine the element. Which is essentially the same thing as our ape number. We know that we look at the atomic number equals the number of protons. So if we know the protons, we also know what element we're looking for. On the other hand, we also know that the valence electrons, a little different. The valence electrons, remember those are the outermost electrons of an element. So the valence electrons determine reactivity. In other words, they determine how an element will bond or react with another element. Okay, so let's look at where we're going to find all this information. Well, the first trend that we notice on the periodic table is that there is a stair-step line, and the stair-step line is there to help you remember that to the left side of the stair step we find the metals, and to the right of the stair step we find the nonmetals. Along the stair step, and we're going to extend our stair step a little bit to remind ourselves, along the stair step we find the metalloids. Now, if you all remember, we also should know by now the properties of metals, nonmetals, and metalloids. Metals are malleable, ductile, they conduct electrical and heat energy. They are shiny or they have luster, whereas our nonmetals are brittle solids. Most are gas at room temperature. They are not ductile, they are not conductors of any electrical or heat energy. So that's basically kind of like the differences between these elements here and these elements here. If you remember correctly, we also have a couple of exceptions that we know of. We know that one of the exceptions here is aluminum. Aluminum is a metal that is touching the staircase where the metalloids are. So aluminum is a metal. And we know that there's one other exception, and the other exception is that hydrogen is in that group 1 with the metals, but it is a non-metal. Alright, so let's move on. So one thing we notice looking at the periodic table are there are numbers here, and there are numbers also going across the top. If you look at these numbers here first, these are the periods or the row numbers. One way to remember that is that we write sentences from left to right, and they always end in a period. Not always, but most of the times they end in a period. So that's one way to remember that the periods are the rows. Now, every element is in a certain row because they all have one similar characteristic, these elements. They all have the same number of energy levels. So the periods or row numbers tell how many energy levels an element has in that row. So if I'm in period 1, I will have 1 energy level, or 1 electron orbital, 1 electron shell. Any way you want to say it, same thing. So, but if I'm in period 2, I'm going to have 2 energy levels. If I'm in period 3, I will have 3. And in 4, 4. So you get it. Each one of these elements in these periods have the same number of energy levels. So no matter which one of these atoms I would like to draw, I can start off by knowing they all have 4 energy levels. An element can have up to 7 energy levels. These at the bottom, these 2 bottom rows have been pulled out of rows 6 and 7, so they belong to 6 and 7. So an element cannot ever have more than 7 energy levels. All right, let's look on to the top numbers. The top numbers up here are showing us the number of the groups. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's see if I have another purple here. 12, 13, 14, 15, 16, 17, and 18. Those are the group numbers. So these numbers are the group numbers. Groups go up and down. So I emphasized up in the word group. So you remember they go up and down. They are the columns on the periodic table. So groups are like families. Well, what does that mean? Well, families share certain similar traits. For example, you might have a similar skin coloring or hair coloring or body type as one of your parents or one of your grandparents. That's because we all share characteristics in our DNA that are similar when we're in a family. So groups are like families in that they also share similar properties. So we're going to look at some of those properties they share right now. One property they share, and if you look very carefully, you will see below the 1 group number is a number 1A, 2A. These have 3 B's, 4B, 6B, 7B, 8B, 9B, or 1B and 2B. So these are really kind of weird, and we're going to talk about that in a minute. And then we continue from 1A, 2A to 3, 4, 5, 6, 7, 8, and 8A. The A's, only the A numbers, are indicate how many valence electron each group or group member in a group share. So these are the number of valence electrons. So in other words, 2A means I have 2A means every element in this column or group 2 or family 2 has 2 valence electrons. So 2 electrons on their outermost shell. So number of valence electrons 2A means each element has 2 valence electrons. So if we were to look at this, group 1 has all of these elements have 1 valence electron. All of them. If you are in group 2, let me see if I can make that a little more dark. In group 2, you have 2 valence electrons. Now, these are all the ones with the A number. The B's, all of the ones with B's are considered transition metals. They're metals, they just don't follow our bonding rules. So these are all transition metals. And they do not follow the rules of bonding that we are talking about. You can remember the B's are the bad boys, they don't follow the rules. So to be exact, where do the transition metals start? Well, they start here with the B's, where you see beneath the group number, a B after the number, these are the transition metals. They're not following the rules. So we're not even going to worry about them for now. We're going to worry about their metals, and on and on and on. But all of these guys are transition metals, and they don't follow the rules that are important for us to know in 8th grade chemistry. So we're concerned with group 1 with 1 valence electron, 1 outermost electron. Group 2 with 2 valence electrons, meaning 2 outermost electrons. And now we're going to skip a few and go to group 13. Group 13 has 3A, so they have how many? Yep, 3 valence electrons. And group 14 has 4 valence electrons. Group 15 has 5 valence electrons. Group 16, 6 valence electrons. Group 17, 7 valence electrons. And group 18, 8 valence electrons. Now we also need to note that group 18 is very special. Remember when we talked about all atoms want a total number of, you guessed it, 8 valence electrons? Well, this group is very special because they all have 8. So we're going to highlight them, make them special, because they are. They all have a full valence shell or 8 valence electrons, meaning they follow the rule of 8. They follow the rule of 8. They have 8 valence electrons or a full shell.